All right, let's talk about solving linear systems of equations by linear combination. We talked a little bit about this yesterday in the 5.06, but today we're going to add one more step. So just a quick review, try adding this linear system together. So we talked about using elimination yesterday. Oops, let me get on my pen. There we go. So when I add this together, 4x plus 2x equals 6x. 3y plus negative 3y cancels out. And 1 plus 1 is 2. So I'm going to divide everything by 6, and I get x equals 1/3. Alrighty, so now I'm going to go back through and plug in 1/3 for x. So I would get 4 times 1/3 plus 3y equals 1. So this would be 4/3 plus 3y equals 1. I'm going to subtract 4/3. So this would be 3y, and this would be like 1 is 3/3. So if I had 3/3 minus 4/3, I would get negative 1/3. I'm going to divide by 3, which is the same thing as multiplying by a reciprocal. So this is y equals, we multiply straight across, negative 1/9. So when we have problems where the coefficients are the same, but they're opposite, like positive or negative, or even if they are the same, we can subtract. But sometimes we don't have where they're the same. So what we can do is, the first thing, we're going to arrange our equations with like terms and columns. So we want to have the x's stacked on top and the y stacked on top. We're going to study the x or the y. So we're looking for, again, same coefficients. If they don't have the same coefficient, we can multiply one or both equations by an appropriate number to obtain a new coefficient that are opposites. Then we'll add the equations so that one of our variables disappear, and we'll solve for the remaining. And then it's back to the same thing that you did in the previous lesson. You're going to substitute that solution back into either equation and solve for the other missing variable and check your solution. So let's take a look at this one. We have 3x plus 5y equals 6 and negative 4x plus 2y equals 5. Okay, so if I look at my coefficients, I don't have any that are the same. But I can multiply, because I have some opposites here. I have a positive x coefficient up here and a negative down here. So let's think of something I could multiply 3 and 4 by to get those to cancel out. So what I'm going to do is multiply the whole top. I'm going to multiply it by 4. The bottom, I'm going to multiply by 3. Because when I multiply the top by 4, I'm going to get 12x. When I multiply the bottom by 3, I'm going to get negative 12x. So now they're going to eliminate each other. So everything gets multiplied by 4. Everything. So 4 times 3x is going to be 12x. 4 times 5y is going to be 20y. 4 times 6 is 24. So don't forget to multiply everything. And on the bottom, everything is going to get multiplied by 3. So 3 times negative 4x is negative 12x. 3 times 2y is 6y. And 3 times 5 is 15. All right, so now I have opposites. I can add them together. I'm going to get 26y equals 39. Divide by 26. And this is actually going to reduce. If we divide the top and bottom by 13, we're going to get 3/2. And now we would just go back through and plug that in. So we would have, you can do it on either equation. So I'm going to do 3x plus 5 times 3/2 equals 6. So I get 3/2 plus 15 halves equals 6. I'm going to subtract this 15 halves. So again, I want to have the same denominator over here. So 6 would be the same thing as 12 over 2. So 12 minus 15 would be negative 3 halves. And 3x, so divide by 3. And I would get x equals negative 3 on top and 6 on the bottom, which is negative 1/2. So trying to get you guys some practice using fractions. So in this case, our solution would be negative 1/2, 3/2. And this is where we would want to use our elimination method, because on a graph, you're not going to be able to see perfectly where these cross. So that's the reason that we're using this combination method, because you're going to get some fractions when you do these sometimes. So a couple tips. When there are fractions in the equation, go ahead and clear those first. But how do we know when to use which method? So sometimes the problems will tell you solve by graphing, solve by substitution, solve by combination, or elimination. Those are the same. If it doesn't tell you, we can use a graph to approximate a solution. So for this last one, it wouldn't have crossed at whole numbers. So we would have to approximate a solution like we did in Unit 5.03. If we want an exact solution, we would use substitution, or we could use this linear combination or elimination method so that we can get exact numbers. All right, so let's go ahead and try this final practice problem. You'll notice we have 8 and 5. Those aren't going to cancel out. Not the same coefficient, they're not opposites, but we do have 2y and a negative y. So since we have a positive and a negative, we're actually going to leave the top equation alone, and we're going to multiply the bottom equation by 2. So we would then get 8x plus 2y equals 16. That's our original. The top one, that's going to stay. 2 times 5x is going to be 10x. 2 times negative 1y is going to be negative 2y. And 2 times 28 is going to be 56. So now we can add these together. We get 18x equals, let's see, that's going to be 72. Divide by 18. So x is going to be 4. And then we're going to take that x value and plug it back in. So we get 8 times 4 plus 2y equals 16. 32 plus 2y equals 16. We're going to subtract 32 from both sides. We get 2y equals negative 16. Divide by 2 for y equals negative 8. So our solution would be 4, negative 8. And this one came out as whole numbers, so that worked out really well.